Okay, we'll get started. Hello, friends. I'm Ram Lakshmanan, architect of the Ycrash product suite. I would like to welcome all of you to this April month webinar, right? This is a monthly webinar series we have been doing. Thank you, everyone, for making into this webinar. In this webinar, we are going to be discussing about common Java memory leaks and how to fix them, right? That is a topic. So without any ado, let's get started. Okay. So friends, when it comes to memory leak, there is actually two predominant patterns. There are several ways in which a memory leak can happen, but there's only two of them are a most predominant pattern. The first pattern is what you are seeing here in the screen. That is, there will be an object in your memory. It will start to grow in size. It will keep on growing. And once it grows beyond your memory limit, then you'll get out of memory error, right? This is the first pattern. Think about it. Let's say you're having a cache in your application. So if you keep on adding the records into that cache without expiring them, then the cache will start to grow bigger in size. And once it goes beyond that, your heap size limit, then you will be thrown out of memory error. This is the first pattern, right? And the second pattern is you will have a same type of objects, right? You'll have a same type of objects. Those objects will keep multiplying in memory for a period of time. Like say, there is a session, right? There's a HTTP session. If you're not closing those sessions will keep on growing. There'll be multiple session objects. So, and multiple session objects starts building up in the memory. When there's not sufficient memory limit, you will be confronting this out of memory error. So friends, these are the two primary types of the reasons why the memory leak happens, which ultimately results in out of memory error. So now let's look into a sample code, which is going to generate out of memory error, right? Which is going to trigger a memory leak and it's going to trigger an out of memory error. So let's look into the sample code. So here, this is an hypothetical code. So this is, let's look into that code. So here is that code. We have this memory leak demo, right? This is a class. This class as an object, right? It's called object one. Now let me go into this object one. This object one as a map manager, right? So this map manager has a method called insert records. So let's look into this insert records. Let's see what's going on. This map manager has an hash map, right? Hash map, it's a collection data structure. So this hash map, look at what's going on in this insert methods. Here, there is an infinite while loop. Here, the while condition says true. That means any thread that enters into this method is going to go on an infinite loop. It's just going to be constantly going to be spinning in this while clause. Let's see what's happening in this first line. Here, I'm saying my map. There is this hash map, and I'm saying I'm inserting a record of value key to be 0, and then the value to be a large string 0, right? This is what I'm doing. And for every 1,000 iteration, I'm just printing like 1,000 records has been inserted. Now the thread once again comes, since the while condition is true, it's going to insert key 1, large string 1 into this hash map. So like this, the thread, if it constantly goes on a loop, it will be constantly adding the objects into this hash map. So we have this hash map, this single object, it will now start to grow in size. And when it starts to grow in size, and when it goes beyond your XMX limit, that what you have configured, then that's when the out of memory error is going to be thrown. So this goes back to the first pattern. That is, there's going to be an object. Most of the time it is in collections. There will be like this hash map. And there this hash map keeps on growing. When it goes beyond that XMX limit, you're going to get out of memory error. See friends, no developer will be putting like this kind of while, they will not say this while true. They will not explicitly do like this. They may have some condition. That condition can turn to be true. On evaluation, it can turn to be true, right? So that's when the records keep on added. And when records keep on building up, then the out of memory error will be thrown. So now let me execute this program. So now I'm going to be executing this program. See, I'm executing it. See, the program is executing. You can see It is printing inserted 1,000 records. It's starting to print. But now it is not printing anymore. So JVM is now struggling a little bit because it is unable to create more objects. See, now this application throw out of memory error. So we got this out of memory error, right? So this is a typical pattern. There will be a object. That object will start to grow in size, and when it goes beyond the limit, you're going to get out of memory error. Now, equipped with this knowledge, so this is the most common pattern. When we say this is the most common pattern, it also means there are also not so common patterns. There is that one what we saw was the most common pattern, but there is also other patterns which is not very common. Like say that a threads can leak. That is in your application, you may start creating more threads without terminating them. If thread starts to build up in memory, then also you will get this out of memory error. Similarly, like unclear thread local, time-taking finalizers, growing metadata objects, like these are the possible reasons where you will get a memory leak. So these are not very common. So what I was planning to do is, in this session, we will focus on this common memory leak, what most of us face. In the next webinar series, we will talk about not so common memory leak, right? That will be the next webinar. We'll go into each one of them scenario, and then we will see how to address them. Okay. So now let's come back here. See, friends, when a memory leak happens, there are some symptoms you're going to observe in your application. What are those symptoms, right? So let's review that. There are 4 symptoms, my friends, your application will start to experience when a memory leak is happening in your application. See, this is an memory behavior of an application which is very healthy, right? Why do I say this is a memory behavior of an healthy application? Look at this. As requests are coming, the memory is building up. Memory keeps on building up. This red triangle indicates it's a garbage collection event. It's a full garbage collection event. When garbage collection runs, it reclaims the memory, right? When this full garbage collection event ran, the memory dropped all the way to the bottom. And then once again, the memory starts to build up. When another full garbage collection event ran, the memory dropped all the way to the bottom. You see this beautiful sawtooth pattern, memory going up, coming down, going up, coming down, right? And if I try to draw a line connecting all the bottom points, it is that black dotted arrow. You can see this is going at a kind of a 0 degrees, right? It's going at a 0 degrees. Now, let's look at how the memory behavior pattern of an application which suffers from memory leak, how it's going to look like. And this is how it will look like. You will see a gradual memory increase. See, look at this. The request is coming, the memory is building up. Now it has gone to this 8 GB limit because this XMX, the heap size for this application is configured at 8 GB. So it cannot go beyond 8 GB. So it went here and then it dropped. Look where it dropped. Initially it dropped to 4 GB. Now, once again, the memory is building up. Now, next time when the event ran, look, it is dropping to 4.5 GB. It didn't drop to 4 GB limit. It's dropping to 4 GB limit. And now it becomes 5 GB, 5.5. So you can see that bottom point is gradually increasing. Is gradually increasing. So if I try to draw a line, slope connecting all the bottom points, look at this black arrow. It is almost going at a kind of a 10 degrees, right? It's almost going at 10 degrees. Whereas the earlier one, this one was going at 0 degrees. So what you will see, you will start to see this kind of memory, the bottom point starting to go like this, going at an inclination. So this is a clear indication that this application is suffering from a memory leak, right? But it hasn't just blasted. The problem hasn't really worsened, right? But when this application continues to run, the application with a memory leak, when it continues to run, this is how the memory behavior will start to look like. You can see it's going up and down after a point. You can see the garbage collection, the red triangle, it keeps on continuously running. There's no gap in between them. You can see it is continuously running, but still the memory is not dropping. It keeps on going like that. Friends, when one full garbage collection event runs, that is, even when there's one red triangle runs, it consumes enormous amount of CPU cycles because garbage collection is a heavy CPU intensive operation. Look what the garbage collector has to do. our application is creating millions of objects. It's creating millions of objects. Now the garbage collector has to examine all those millions of objects and see whether those objects have any references. Because if there are objects with references, it shouldn't remove that object from the memory. So it has to check what are the objects which has the reference. Okay, so let's say there is an object here. So now it's going to go, the garbage collector will check, whether this object has any references. Yes, maybe this object is referenced by 3 other objects. Now then, the garbage collector has to go and check all those 3 other objects as well to see whether they have any references. Like this, it has to walk that entire hierarchy to see whether there are any active references for the object. If there's no active references, then it has to be removed from memory. So it has to walk through all these objects and the reference chain. So it takes a lot of CPU cycles. Even when one red triangle runs, the CPU will be going high, like a 90-95%, and then it will drop. Whereas here, look at this, what's happening. Here, the red triangles, that is a full garbage collection, are continuously running. They're continuously running. The CPU consumption will be at a 95, will be at a close to 100%. Will be close to 100%. So it keeps on going like this. So CPU will be 100%. Friend, this is a golden rule. Remember always, whenever a memory leak worsens, always CPU will also spike up. It's interconnected, right? When there's a memory leak and it really worsens, the CPU will also spike up and it will remain at 100%. If CPU spikes up, you didn't make any code change, nothing. If CPU spikes up and goes to 100%, remains there. There's a very good chance it's a very good indication that your application is suffering from a memory leak. So this is a second symptom. You're going to see elevated CPU consumption when memory leak really worsens. And the third symptom, what happens to your application is you will start to see a degraded response time and timeouts will start to happen. Because, my friends, when a garbage collection event runs, it stops your JVM. It actually pauses your JVM, like you want to visualize, as if you're watching a YouTube video clip. You're watching a YouTube video. If you click on the pause button, what will happen? The video will not play, right? Similarly, when garbage collector runs, it stops your JVM. It stops the JVM because if it doesn't stop, your application threads will keep modifying the objects. We always create objects, we rechange the pointers. Application does this always. So garbage collector cannot proceed if application thread is meddling with the object pointers. So it stops the JVM. But here, if you see, when towards the right side, besides the CPU consumption, it's also stopping the JVM. So here you can see continuously the JVM is getting stopped. The JVM gets continuously stopped. So what's going to happen if it's stopping, the JVM gets stopped? That means any customer transaction which is coming, they will not be processed. Or what are the customer transaction in motion? They will not get a response immediately. So your response time will start to degrade. And if in this kind of, towards the right end of the graph, if you see, it is continuously pausing. If it's continuously pausing, you'll start to see timeouts. So your health checks can also start to fail. So this is the third side effect of memory leak. And finally, the final symptom is when problem really worsens, there's no more objects can be created. At that point, JVM will throw out of memory error. It will throw out of memory error in your application. Right? This is the final resort, what JVM does. So to recover the situation. So you get out of memory error. So in a nutshell, there are 4 symptoms. The first symptom is you're going to see a gradual memory increase. And when the problem really worsens, you're going to see a CPU spike and poor response time and timeouts. And as a final result, your application will experience out of memory error. Right? So these are the symptoms. Now, let's discuss how to fix a memory leak. How you want to go about fixing a memory leak. Friends, here I'm talking about the most common type of a memory leak, right? In next webinar, we'll talk about not so common type. So the most common type is when you get, like the example we saw, you are going to get out of memory error thrown, right? So the first step in the diagnosis, what you want to do when you get a memory leak is how to go about diagnosing. Look at the out of memory error stack trace. Look at the stack trace. The stack trace gives you a very strong indication of where the problem is going on. Let's come back to this example, what we were looking. See, here we got out of memory error. Right? We got out of memory error. So in this out of memory error, it tells me the stack trace. See, so here you can see, oh, it is happening in this map manager insert records here. So here I can see when it's trying to create this string object, that's when it couldn't create. That's when it couldn't create any more objects. See, it is happening exactly in this line number 23. It's trying to create a string. And it's not because there's no more sufficient room in memory, it is getting thrown. So this is a strong indication of where the memory leak is happening. This is one indication, but not a very clear indication, because it could be quite possible that memory leak source may be happening in some other point. Maybe when your thread is executing a different code path, you may get, but this is a good indication. So you want to look at the stack trace. So this may tell where the problem is there. And this is the first thing what you want to be looking. And then another one that what you want to be looking at is in this stack trace, we always look at only this out of memory error. Friends, after this session, consider looking after this colon. Here there is an indication which says, it says GC overhead limit exceeded. So this says what type of out of memory error we are getting. Based on the type of out of memory error, diagnosis approach will vary. Actually, there are 9 different types of out of memory errors. We have discussed that 9 different types in our earlier sessions. But GC overhead limit exceeded and Java heap space, this is the most common type of out of memory error. Probably 90% and 95% of out of memory errors happens because of this reason, right? GC overhead limit exceeded, right? Or Java heap space. This may happen interchangeably. Okay. So now let's come back. This is the first step. I want to look at the out of memory error, look into the stack trace to see to give an indication like from where the problem is originating, right? Now the second step that what I want to be doing is I want to study the garbage collection behavior. That is, I want to see what is happening in the garbage collection. The garbage collection gives me a very clear indication of what's going on in the memory, right? So especially when you're diagnosing out of memory error or memory leak or any memory related problems, studying the GC behavior will really help you. How can I study the garbage collection behavior? What is the best way to study the garbage collection behavior? Friends, you can use APM tools if you have, which is a good thing to do. But APM tools gives you only a subset of information and it doesn't give you much detailed wealth of information. And also this APM tools adds considerable overhead to your JVM. So the best way that you can do to study the garbage collection behavior is by enabling the garbage collection log. You can enable the garbage collection log on your JVMs. So say you can pass this sort of an argument. Say if you're running on Java 8 or before versions, you can pass this sort of arguments and give the file path. When you do that, the JVM will start to write the garbage collection log, garbage collection event information into this file path, whatever you have described. If you're running on Java 9 and above version, you can specify this as the path. So then the GC log will be generated here. And friends, most of you might have enabled this GC logging already in your production servers. If not, you can consider enabling it, because this enabling the GC log adds very, very minimal or almost zero overhead does that to your application, right? It does not add any noticeable overhead. In fact, in our blogs, we have presented a white paper showing what is the overhead it's adding, right? Which is almost close to zero. Okay, so now once I've enabled, the garbage collection log will be generated. So how do I analyze the garbage collection log? Garbage collection log is a tedious cryptic file. So what you want to do is you want to use some kind of a GC log analysis tools, like a GCEC made by our company is one of the tools. And there's also other tools are also available. You can look at it and look into that. So now let's analyze this GC log. Let me show you how to look into this GC log. So there's this tool GCEC. It is available online. Also, it is also available as an on-prem installation as well. If you want, you can download the tool and run it on your local machine as well, right? So now this is the tool. To this tool, I'm going to be uploading the GC log file, right? The what we generated by enabling the GC ordinate. So now once I upload it, the tool is going to analyze. And if it has detected any memory leak or any GC problems, it will start to report at the top. Oh, here it says a memory leak has been found. By looking at the GC behavior pattern, it will tell you. And it will also give you kind of recommendations on what you can do to improve your GC performance. Like example, increase this parameter value, set this value. We give you the kind of recommendations. Why this is telling that there's a memory leak is happening? Because see, look at this. Memory is going up and down, and then it's not coming down at all. And also here, there's a thing called as which shows the reclaimed bytes. It shows how many bytes are reclaimed on every garbage collection event. You can see, my friends, on the right side, when the problem has really worsened, when the problem has really worsened here, look at the reclaimed bytes. You can see the reclaimed bytes has come down to almost 0. Nothing could be reclaimed, right? Whereas earlier it was able to reclaim some data. It was able to reclaim like a 2.7 GB, 2.3 GB data, and it was able to reclaim the earlier achievements. But as when problem occurs, it's unable to reclaim anything, right? Okay. So now by looking at this garbage collection behavior, you can confirm, yes, the memory leak has happened in my application. So this is what a pattern is. Okay. So this is the second step in the process. Now the third step, and probably the most important step, is I want to do the heap dump analysis, right? What is a heap dump? So friends, heap dump is nothing but a photograph I'm taking on my memory. So I'm taking a photograph of my memory and then I'm writing into a disk. So that information, that the heap dump contains all the objects which are there in memory and what is the value that is there in that object. Who is referencing those objects? It contains all those information. So I need those information to see what are the actual leaking objects and from where the leak is originating, right? So how to do this heap dump analysis? So to do this heap dump analysis, first step is you need to be capturing a heap dump. I need to capture a heap dump. How can I capture a heap dump? Friends, here is a blog post I'm sharing with you. It shows you like 8 different options to take heap dumps, right? You can use like a JDK commands are available, like a jmap command is there, from which you can take an heap dump. And or the other option, an effective option, which works very well, is to your JVM itself, you can configure this argument, heap dump on out of memory error, and then pass this path, file path. So whenever an out of memory error happens, automatically heap dump is going to be captured and returned into the disk. So you don't have to worry about capturing the heap dump. So automatically, whenever out of memory happens, heap dump is going to be taken and returned into this file path. Now it is available for us to take it and then diagnose it. So similarly, there are more such options. I'm not going to be going into every option because of interest of time, but the link has been given. You can look into that. Okay. So now we have captured the heap dump, right? But friends, look at this. Whenever there is a production problem happens, see, no one is going to come and say, oh, there is a memory leak is happening, go ahead and look at it. People might, your support team or your alert might say, oh, the application is starting to time out. Application is going to become unresponsive. So at the heat of the moment, this unresponsiveness can be caused because of memory leak, or it can be also caused because of some backend is slowing down. Or what if there is a network latency, or there is some kernel issues? It can happen because of any reason. So friends, the best way to equip yourself to troubleshoot production problems, or even in our life, say I'm in a territory in which I don't have much information, but I need to solve a problem. How do I do it? The best way to do that is equip yourself with enough data. Equip yourself with sufficient data. If you have sufficient data, then you can make right decisions. So friends, here I'm sharing an open source script. So this script is available in GitHub in this location. So this script, you can trigger it like this, yc-p process ID. When you give your process ID, that is application, current production application, which is having a problem. Now this script is going to capture you a 360-degree data from your application stack. It's going to capture GC log automatically, thread dumps, heap substitute, top, PS, kernel logs, more importantly, application logs. Application log contains wealth of information. So it captures this wealth of information, which includes heap dump, which we need to troubleshoot memory leak. Plus, it also captures the GC log based on the file path that is configured in the JVM. It automatically picks it up. And it auto discovers all this information, the application log and all. You don't have to give the file path. The script itself figures out, oh, these are all the file descriptors to which your application is writing. So it picks up those paths. It gets those information and then bundles them up as a zip file and then drops it for you. So now we have all the data to troubleshoot. So to take a heap dump, you can either use one of the 8 options that's shown earlier, or you can use this one script, which captures 360-degree data, which not only facilitates you to troubleshoot memory leaks, but also any production problem, any production performance problem. Okay, so now I have taken the heap dump. How do I go about analyzing the heap dump? Friends, there are heap dump analysis tools, like Heap is one of them. Eclipse Mat is another one. There are also other tools are also available. So now let me walk you through the most simplest way to get how to do the heap dump analysis. So now what I will do, I'm going to, for my demonstration purposes, I'm going to be using Heap tool, but if you are welcome to use any tool of your preference. Now, let me, so this tool, this Heap tool is available online, or it's also available on local host. You can download and install it on-prem on your local laptop. So now I'm going in here. Let me upload the heap dump that we for this memory leak demo, what we walked through in the beginning. So let's look into this, upload this heap dump file, and then let's see what it's displaying. So now here's my heap dump file. I have it saved earlier. Okay. So now I'm uploading the heap dump file. So see, the heap dump file tends to be large in size, so it takes some time to analyze. But see here, this tool also gives you an API approach. So from your production server itself, you want to do the analysis, you can trigger an API. Or you can also analyze from any remote locations also, right? Okay, so now I upload the heap dump, the tool has analyzed, and then it reports, it generates a report. At the very top itself, the tool has detected any memory leak. It's going to inform you, oh, here there is our algorithms as detected. See, it says this is that class, the map manager class. So this is the class, what we are working on, map manager, is occupying this much space. 99.95% of space is occupied by just one single object. Examine what's going on. It gives all this information. But friends, you can click into these details and then see. But let me tell you, the common pattern is that we discussed, there is going to be a single object which is going to keep on growing. And when it goes beyond a size, then it's going to explode, right? So always, when there is a memory leak happens, look at the topmost object in the memory. Most likely that is a guy, which is the culprit guy, which is causing the memory leak, because the biggest object is the one which has been growing, and that is the one which is going to be causing the memory leak. So look into the largest object. So in this report, there will be a section called largest objects. It's going to display all the objects in our memory sorted by the size. So here we have this map manager. This object occupies like a 99.95% of my memory. So this is the culprit. Okay. So now I want to know, okay, this is the culprit. I want to know what value is there in what are the elements which is there in this map manager, so that it has grown so big in the memory. To do that, click on this more. And now here, click on the outgoing references. Friends, what is outgoing references? Outgoing reference means the references that are going outside from me, from this object. That means what are my children? What are the references going outside from me? So these are the guys which is building up in the memory. So let me click on this outgoing reference. Now when I clicked on this outgoing reference, you can see this map manager has some children. But look at this. This hash map, there's an hash map inside. This is what occupies most of the size. See, this parent size is 469 MB. So this guy size is also 469 MB. Almost it is what is occupying the full length, the full size. So this hash map. Look at is this so here's the hash map manager. See, it has an hash map. Look, my friends, interestingly, it also you also get to even see the variable level information. Here you see there is this my map, which is present. This is a variable, my map. What I'm using, the variable is present. So now let me drill down. Okay, this is the largest topic. I'm drilling down. Friends, hash map internally as a table, right? That's how it's implemented in the JDK. You can see when I clicked on this hash map, you can see it is displaying all the records in that hash map. You can see it's displaying the initial 10 of 1,152,000 records are here. So in this hash map, we have added 1,052,000 records because we were going on an infinite while loop here. We are going an infinite while loop. We kept on adding the objects. So this tells we went on a loop for 1,052,000 times. So 1,052,000 records got added. That's why it's so big. If you want to examine what is the value that is there, just click on this object on one of the record. When I click on one of the record, I can inspect actually what is the real value. Look at this. Here I can see a key. Oh, this is the key I added. And this is the large string that I added. I can even go to the level of what is the raw objects that got added here. Okay, now I know. Okay, this is the objects which has been growing in the memory, right? Okay, this is good. But now my next step is, okay, so this is the guy which has been growing, but who is keeping this object alive in memory? Why it is unable to get removed? Why it is not getting garbage collected? So which part of my code contains this object, right? Because see here in the example I showed, it is a very simple code, but our application code has thousands of classes. So where it is originating, from where who is keeping them alive? To do that, friends, come to the same more, click on this, and then click on incoming references. Incoming references to see who are all referencing this object, which is keeping them alive. Who are its parents, which is keeping him alive. So let me click here, the incoming references. So it's opening a new tab. So here, I can see this map manager is referenced by object 1 with this variable map manager. Look at our code. Let's go to the code. See, this is the object 1. It's referencing this map manager with this variable map manager. Now, who is referencing this object 1? To do that, let me click here. If I click here, I can see this object 1 is referenced by memory leak demo. So I can like this walk through to see who is holding on to my reference. So I know, okay, this is where the references chain is coming, which is keeping the object alive. Okay. Okay. So with this information, this is all we need to see which is the biggest object, what are the children that kept it growing, and who is its parent pointing to. With this information, we can go ahead and we can fix the leak which is happening in our code. That's all it is. It's no rocket science. Very basic things. Okay. And friends, going to the second pattern, right? We discussed the first pattern is one single object which is kept on growing. The second pattern is a particular type of objects can keep multiplying, right? Even when that happens, here, if you come to this largest objects, you will start to see those multiplying objects displayed here. So you can click on them and then you can do the same thing. You click on the outgoing reference and incoming reference, right? There are also other sections are also here. You can look at it, but just this one section itself is good enough to get to the root cause of the memory leak. Okay. So now let's move forward. So this is the approach to diagnose and identify the root cause. Okay. So now, is there any way that I can predict the memory leaks in my performance lab? Why memory leaks are happening only in production? Why we are not unable to uncover them as part of our performance test? What is the reason? Friends, there is one primary reason, right? Look at this. This is the memory pattern of a memory leak, right? When a memory leak happens, this is how the memory consumption looks like. It just keeps on growing. And then after a point, it never comes down. And when it reaches the ceiling limit, out of memory error is going to be thrown. Friends, most memory leaks happens gradually over a period of time, right? It doesn't happen instantly. Sometimes it can happen also instantly, but most of the memory leaks happen slowly. The memory keeps building up slowly, and then you're going to confront. In our performance lab, most likely we are running probably a 1 hour test or a 2 hour test. In that 1 hour or 2 hour test, probably our test ends here. Maybe if I draw a line, I should have drawn a line here. It ends almost here. So today in our performance labs, we are looking at only at a macro metrics, right? We are looking at what is a CPU, what is a memory, what is the response time. When you are here at the 2 hour limit, what you're going to see is you'll see the memory more or less same. The response time still going through, and there's not CPU spike will not going to happen because it's going to happen only at the end. So the memory leak happens. It does happen in a performance lab, but at an acute scale. And we don't look at it, we only look at the macro metrics, which is not big enough to get our attention. So if you start to look into the garbage collection behavior, if we start to look into the garbage collection behavior, see here, in this garbage collection behavior, there is a metric called throughput percentage. So this tells how much time your application is spending in processing the garbage collection activity and how much time it's spending in the GC in processing the customer transactions. If an application is having a memory leak, this throughput will degrade. So you want to check what is my throughput, GC throughput in the previous release and the new release which is going to go live. If there is a deviation, then that is something you want to address. And then also, if you see this kind of a trending going high, the tool itself can detect and tool itself will tell, oh, there's a memory leak is going on. So just take your GC log and do the GC analysis. And if you see this kind of a trending, it will raise an alert for you. So that's an indication. So you don't have to, even in the performance lab, even if you do 1 hour or 2 hour test, you can still be able to catch it. So you want to be looking into the GC behavior in your performance lab to forecast these memory problems. And then the second metric that what you want to be looking at in your performance lab is look at the object creation rate, which is also reported. These are all the micrometrics, which is not available in the APM tools or whatever you're looking today. So here there is a thing called object creation rate. What is my average object creation rate? It says 8.37 MB. That means I'm creating 8 megabytes of object every second. What if in your previous release you are creating only 4 megabytes per second? Maybe a developer has committed some inefficient code into memory, has committed some inefficient code in the new release. So that is for the same workload, we are creating more objects, right? So we want to look into these kind of micrometrics, and these kind of micrometrics help us to forecast any memory problem that's going to happen in production. Okay. So friends, I'm going to tell you a good news now. The good news is this webinar is coming to an end. Right? It's coming to an end. But before I end, there's a couple of things I want to share with you. In case if you're not bored with this session, and if you want to learn more about JVM performance engineering and troubleshooting, you may register here on this online class, and then you can study at your phase, whatever you want to do, at your regular phase you want to do. So thank you everyone for taking your valuable time and attend this session. So we will continue this journey. Thank you everyone, right? Thanks for taking your valuable time. See you guys. Bye.